Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today, we are continuing on with TryHackMe. This is the Cybersecurity 101 learning path. This is the command line module, and this is the Linux shells room. Learn about scripting and the different types of Linux shells. Now, hopefully you're all having an awesome day today and ready to learn. Let's go ahead and dive into it. Task 1, Introduction to Linux Shells. As regular users of operating systems, we all extensively use graphical user interfaces, also known as GUIs, to carry out most operations. It takes a few clicks on different options, and your task is done. However, you can perform almost every task by writing commands in the CLI, which is the command line interface, of your operating system rather than using the GUI. The shells give you some great features for the commands you write in the CLI. This way of interacting with the OS, which operating system, is more efficient and resource friendly. Suppose you are in a restaurant and have two options for your food. The first option is to order food from the menu and the waiter will serve it. The second option is to cook your desired dish yourself in the kitchen. In terms of Linux system, the kitchen here is the OS, and using the GUI of the OS is just like ordering the food from the menu, and the waiter will serve it for you. However, using the CLI means you would have to go to the kitchen, the OS, and cook your desired food. In this example, Shell would help you cook your desired dish by giving you some recipe suggestions. Using CLI to perform operations in a Linux system gives you more power and control while carrying out the tasks. You may have seen hacking scenes in movies that show cool terminals with many commands getting executed. This is because most Linux users prefer to use operations to perform operations by writing commands on the CLI using shells instead of the GUI. This room will teach us how to interact with a Linux shell. We will also explore different shells available in Linux and write some shell scripts in the end. Learning objectives. Learn interaction with Linux shells, use basic shell commands, explore the types of Linux shells available, and write some shell scripts. Room prerequisites. So check out the Linux fundamental module if you haven't already. Who is the facilitator between the user and the OS? Well, that's going to be the shell. And task number 2, how to interact with the shell. As you can see, I've already started up the machine here. All right, so follow these instructions if you want to start the machine, or you can also navigate or connect to this machine via SSH using these credentials here. All right, and let's go ahead and skip down some here. It says most Linux distributions use Bash, which is born again shell, as the default shell. However, the default shell displayed when you open the terminal depends on your Linux distribution. In the upcoming task, we will discuss different types of shells. You would have already explored basic commands in the Linux fundamentals module mentioned in this room's prerequisites. Let's briefly discuss some of the most important ones we use in the shell. When interacting with the shell, you must be in the directory where you want to perform operations. By default, when you open a shell in most of the Linux distributions, you will be in your home directory. To see your current working directory, you can execute pwd, which stands for print working directory, as shown in the terminal below. So first off, we are going to clear all this out using clear, and then we're going to do pwd like so, and get this out of the way. So we're in the home user directory, okay? And let's go ahead and continue. However, you can change directory as well. To do that, you can use the CD short for change directory as shown in the terminal below. All right, we did pwd. Okay, I also switched to the desktop directory, as you can see here. Okay, if you want to do that, you can use the CD to go back to different directories. All right, ls, and then you have Ubuntu user right there. Okay, and you want to CD into Ubuntu like so. Do an ls. There's desktop, so CD into desktop like so. There you go. And let's go ahead and continue on here. It says, however, you can change your directory as well. To do that, you can use the CD for short for change directory as shown in the terminal below, which we just did. While using the GUI of an OS, you can see the contents of a directory on the screen. However, while using the shell to see contents of a directory, you must enter the following command, which is ls, which I just showed y'all. So you can do ls again, and there you go. If you want to read the contents of a file, you can type the following command in your shell, which is cat, and then whatever the name of the file is. So if we go back here, and there's nothing in here. Okay, so let's go into user. Okay, I believe that had something in there. There we go. So we can do cat flag. All right, there we go here. That's what's in that file. The grep command is a very popular command among Linux users. This powerful command can search for any word or pattern inside a file. Suppose you want to search for specific entries in a huge file. You can use the grep command along with the pattern of those entries, which will extract them for you. It also helps you to search for a specific keyword in a big file. The following terminal shows us how to use grep command to search for the word THM inside a big text file. The output displays the specific file line of that text file containing this word. So they did grep THM in this dictionary.txt file, and it says the flag is THM. Awesome. What is the default shell in most Linux distributions? Remember that's bash for born again shell. Which command utility is used to list down the contents of a directory? Remember that's ls. Which command utility can help you search for anything in a file? Remember that's grep, right? Task number 3 is types of Linux shells, and let's see what they say about this here. Like Command Prompt and PowerShell in Windows OS, Linux has different types of shells available, each with its own features and characteristics. Multiple shells are installed in different Linux distributions. To see which shell you are using, type the following command. You can use echo and then $shell in all caps. So let's go ahead and clear all this out and follow along here. Echo $shell. There we go. Bash. You can also list down the available shells in your Linux OS. The file etc shells contains all the installed shells on the Linux system. You can list down the available shells in your Linux OS by typing cat and then etc shell. So I'm going to copy and paste this over like so, and let's see what's on here. So we got regular shell, bash, bash, rbash. And you can see the rest of their dash, z shell, etc., etc. And let's continue on. To switch between the shells, you can type the shell name that is present on your OS, and it will open for you as can be seen below. So they're getting into Z shell looks like. Let's clear all this out again. Let's type in Z shell. Okay, now we're going to switch over into it. This is the Z shell configuration function for new users, yada yada yada. So let's go ahead and I guess continue. Echo and then shell. It says we're still using bash, but let's see. Let's continue on here. If you want to permanently change your default shell, you can use the command chsh-s and then the shell location. This will make the shell as the default shell for your terminal. There are many types of Linux shells. We will discuss a few of them and their features. So let's see here if we can do this again. Exit, creating the file. Continue to the main menu, populate your blah blah blah. All right, so let's just go ahead and continue on here. Born again shell bash is default shell for most Linux distributions. When you open the terminal, bash is present for you to enter commands before bash. Some shells like sh, ksh, and csh had different capabilities. Bash came as an enhanced replacement for these shells, borrowing capabilities from all of them. This means that it has many of the features of these old shells and some of its unique abilities. Some of the key features provided by Bash are listed below. Bash is a widely used shell with scripting capabilities. It offers a tab completion feature, which means if you are in the middle of completing a command, you can press the tab key on your keyboard. It will automatically complete the command based on a possible match or give you multiple suggestions for completing it. Bash keeps a history file and logs all your commands. You can use the up and down arrows keys to the previous commands without typing them again. You can also type history to display all previous commands. Okay, so let's go ahead and clear all this out, and you can type in history like it said. Okay, now you can see I have clear in there ls. Okay, you can do dir print working directory ll. Okay, it's not found. Let's see here. You can do IPA. There you go. Okay, so you can clear all this out, and then you type in history. There you go. Let's continue on. Friendly interactive shell. Friendly interactive shell, which is fish, is also not default in most Linux distributions. As its name suggests, it focuses more on user friendliness than other shells. Some of the key features provided by fish are listed below. It offers a very simple syntax, which is feasible for beginners. Unlike Bash, it has auto spell correction for the commands you write. You can customize the command prompt with some cool themes using fish. The syntax highlighting feature of fish colors different parts of a command based on their roles, which can improve the readability of commands. It also helps us to spot errors with their unique colors. Fish is also uh, Fish also provides scripting, tab completion, and command history functionality, like the shells mentioned in this task. I've used Fish before a long time ago. I usually just stick with Bash. I've also used Z-Shell a little bit as well. Z-Shell, or ZSH, is not installed by default in most Linux distributions. It is considered a modern shell that combines the functionalities of some previous shells. Some of the key features provided by Z-Shell are listed below. Z-Shell provides advanced tab completion and is also capable of writing scripts. Just like Fish, it also provides auto spell correction for the commands. It offers extensive customization that may make it slower than other shells. It also provides tab completion, command history functionality, and several other features. And you can see the features here. You got feature, bash, fish, Z shell, right? Full name. The full form of bash is born again shell. The full name of fish is friendly interactive shell. The full name of Z shell is Z shell. And scripting, you can see the rest here, so be sure to read through this. All right, we're going to continue on. Selecting the best Linux shell depends on your usage and its features. The shells discussed in this task are some of the many different shells available in Linux. You can compare the features of these different shells and choose the best one based on your task. What shell comes with syntax highlighting as an out-of-box feature? Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. If we take a look here, we can see that the syntax highlighting can be used with the shell by introducing some plugins. And let's see what this is. It says it's Z shell. The other one says the syntax highlighting is built into the shell, so that's going to be fish. So that should be your answer, fish. Let's go ahead and type that in. What shell does not have auto spell correction? So if you go back and take a look here and try to find that out, let's see here. Okay, that is going to be bash for sure. Which command displays all the previously executed commands? The current session, that's going to be the history command. There you go. Task number 4, shell scripting and components. And let's see what they say here. A shell script is nothing but a set of commands. Suppose a repetitive task requires you to enter multiple commands using a shell. Instead of entering them one after one on every repetition of that task, which may take more of your time, you can combine them into a script. To execute all of those commands, you will only execute the script, and all the commands will be executed. All the shells mentioned in the previous task have scripting capabilities. Scripting helps us to automate tasks. Before learning how to write a script, we need to know that even though Linux shells have scripting capabilities, this does not mean that you can only make a script using a shell. Scripting can be done in various programming languages as well. However, the scope of this room is to cover scripting using a shell. The first step is to open a terminal and select a shell. Let's go with the bash shell, the default widely used shell in most distributions. Unlike the other commands, we type in the shell. We first need to create a file using any text editor for the script. The file must be named with an extension .sh. The default extension for bash scripts, the following terminal shows the script file creation. So if we do let's go ahead and clear all this out, and ls, okay, we're in user directory. Let's just follow along. Let's do nano, and then first underscore script .sh. Okay. Every script should start with the shebang. Shebang is a combination of some characters that are added at the beginning of a script, starting with the pound and the exclamation point. So let's go ahead and put that in there. Followed by the name of the interpreter to use while executing the script. As we are writing our script in bash, let's define it as the interpreter, shebang. So shebang and then /bin /bash. Okay. We are all set to write our first script. There are some fundamental building blocks of a script that together make an efficient script. Let's learn and utilize these script constructs to write one script ourselves. Variables. A variable stores a value inside it. Suppose you need to use some complex values like a URL, a file path, etc. several times in your script. Instead of memorizing and writing them repeatedly, you can store them in a variable and use the variable name wherever you need it. The script below displays a string on the screen. Hey, what's your name? This is done by echo command. The second line of the script contains the read name. Read is used to take input from the user, and name is the variable in which the input would be stored. The last line uses echo to display the welcome line from or for the user along with its name stored in the value. Okay, so we go in and just put this in there like so. All right, paste this in. There we go. Okay, let's see if I get rid of some of the space in here. Here we go. All right. To execute the script, we first need to make sure that the script has execution permissions to give these permissions to the script. We can type the following command in our terminal. So first, let's go ahead and save this. And to do that, we need to do control, and then we can do O, save it. Okay, now hit control X and clear all this stuff out. ls. Okay, there's our script there. And so chmod plus X, make it executable, and then first script. Okay, should be good to go now. Now that the script has execution permissions, use the dot forward slash before the script name to execute it. We use dot forward slash before the script to run rather than typing the script name directly because dot forward slash tells the shell to execute the file that is present in the current directory. If you don't define dot forward slash before the script name, the shell will search the script in the path environment variable that contains all the directories except the current one, and it will not find the defined script in any of those directories and generate an error. The below terminal shows the script in which we utilize the variables, so let's go ahead and do that here. Dot forward slash and then first. Okay, what's your name? WireDogSec. There we go. Welcome, WireDogSec. Awesome. Loops. Loop, as the name suggests, is something that is repeating. For example, you have a list of many friends and you want to send them the same message. Instead of sending them individually, you can make a loop in your script, give your friend list to the loop and the message, and it will send that message to all your friends. For a general explanation of loops, let's write a loop that will display all numbers starting from 1 to 10 on the screen. So let's go ahead and do that. All right. So we'll go ahead and do nano and what do they call this? Okay, just loop script. So loop underscore script.sh. Okay. And let's go ahead and copy and paste this over like so. So you can take a look here. Bash again. It says for I in 1 to 10, do echo $I done. Okay. So there we go. Control X and want to save it. Okay. So it should be good to go now. If you do an ls on it, okay, there it is. Now we got to do chmod, make it executable, remember. So let's go ahead and do that. Awesome. So now we should be able to run this and see what it does. There we go. It says the first line has the variable I that will iterate from 1 to 10, execute the below code every time. Do indicates the start of the loop code, and done indicates the end. In between them, the code we want to execute is, or execute in loop is to be written. The for loop will take each number in the brackets and assign it to the variable I in each iteration. The echo $I will display this variable's value every iteration. Now let's execute the script after giving it the execution permissions, which we've already done. The output of the above terminal is to cut to 3 numbers only for demonstration. However, when executing according to the script's logic, it would display numbers 1 to 10, which we can see here. Conditional statements. Conditional statements are an essential part of scripting. They help you execute a specific code only when a condition is satisfied. Otherwise, you can execute another code. Suppose you want to make a script that shows the user a secret. However, you want it to be shown to only some users, only to the high authority user. You will create a conditional statement that will first ask the user their name, and if that name matches the high authority user's name, it will display the secret. So let's go ahead and do that here. I'm going to copy and paste like so. All right, let's go ahead and clear all this out, and let's see what they call this one. Conditional script. Okay, so let's do it again. Nano conditional underscore script dot sh. Okay, then we're gonna paste this in here. There we go, and go ahead and save it. Done. Crawl this out. ls, and there it is. So we gotta do chmod on it again, plus x conditional script. Okay, now let's go ahead and continue to read on here. It says the above script takes the user's name as input and stores it into a variable. Study in the variable section. The conditional statement starts with if and compares the value of that variable with the string steward. If it's a match, it will display the secret to the user, if or else it will not. The fi is used to end the loop. Following in the terminal is showing the script execution when the username matches the authorized one defined in the script. Okay, let's go ahead and do that here. So stop / then conditional script. Okay, let's try my name first. WireDogSec. Sorry, not authorized. Now let's run it again, and it said Stewart. So there you go. However, the following terminal shows the script execution when the username does not match. We already saw that here. Comments. Sometimes in code, the code can be very lengthy. In the scenario, the code might confuse you when you look at it after some time or share it with somebody. An easy way to resolve this problem is to use comments in different parts of the code. A comment is a sentence that we write in our code just for the sake of our understanding. It is written with the dot or the pound sign followed by a space and the sentence you need to write. For example, let's rewrite the script we discussed in the conditional statements section and add comments to it. Okay, so added comments here, defining the interpreter, asking the user to enter a value, storing user input and value, and you can see the rest there. So let's just go ahead and copy and paste this over. Okay, went too far. Let's try this again. Okay, there we go. And let's go ahead and clear all this out. And we're gonna do nano again. All right, whatever. Let's just do it this way. Okay, there you go. And I'm just going to delete everything out of here. Okay, then I'm just going to paste everything in with the comments in the code now, so it makes it a little bit more easier to read. Okay, I recommend using comments as much as possible so people can understand what you're doing. Okay, and what happened here? Let's go ahead and save this. Okay, let's try it. Let's double check here. Okay, yeah, looks good. Exit, clear it out. And we can run this again. Okay, let's type in some garbage. Run it again. Okay, still works. Awesome. See how easy a script looks with comments? Comments don't affect the working of any script. A good script always has some comments. The example shown above contains a comment for each line. This is just a better explanation of its concept. However, the best way to include comments is to define them in the major and complex areas of the script. Other types of variables, loops, and conditional statements can also be used to achieve different tasks. Moreover, multiple lines of comments can also be added with a single comment. However, it is not the scope of this room. What is the shebang used in a bash script? Okay, remember that's going to be the this here. So I'm going to copy and paste that down here. Okay, which command gives executable permissions to a script? Remember that's going to be chmod, and it should be plus X. Which script functionality helps us configure iterative tasks? This one should be loops. Remember, they were talking about the for loops earlier. Task 5, the locker script. Let's see what they say here. In the previous task, we studied variables, loops, and conditional statements in shell scripting. Let's use that knowledge to create a shell script that utilizes all these components. Requirement: a user has a locker and a bank. To secure the locker, we have to have a script in place that verifies the user before opening it. When executed, the script should ask for the user or ask the user for their name, company name, and PIN. If the user enters the following details, they should be allowed to enter, or else they should be denied access. Username is going to be John, company name TryHackMe, and PIN is 7385. Okay, and this is the script here. All right, so I'm going to go ahead and get this ready to go. And all right, so we just take a brief look at this script here. Define the variables. Okay, you got username, company name. You got the PIN here. Defining the loop. All right, for I and 1 to 3, do the following. Defining the conditional statements. If I is equal to 1, then echo user or enter your username, read the username. If I is equal to 2, then echo enter your company name, okay? Else echo enter your PIN, then read PIN, and then done. Checking if the user enter the correct details. Okay, you got username equals to John. All right, so if the username is John, that's good. And the company name is TryHackMe, and the PIN is that, then authentication successful. You can access your locker, John. Else authentication denied. So let's go ahead and do that here. Let's go ahead and clear this out and do a nano. And what did they call this? Just locker script. So locker underscore script.sh. There we go. And let's go ahead and paste everything in. Control X, and want to save it? Yes, we do. Clear this out again. Chmod plus X, make it executable, right? So let's do locker script. There we go. Now we're going to and fire this off. Okay, there we go. And it says it's giving me an error message here. All right. Now I'm not sure what happened. I didn't copy and paste correctly, but anyway, I opened up Notepad here and I pasted the information here. Okay, and then I copied it out of Notepad and pasted it into this locker underscore script file. I've also switched back over to the bash shell. Okay, now it should be working. So let's go ahead and do it. Remember, you have to do chmod plus X to make it executable. Okay, so don't forget that. Now let's go ahead and run it. Okay, John should be our name, or if I can spell John correctly, John. Company name is going to be TryHackMe, and then the PIN was 7385. Okay, authentication successful. Awesome. Now we can try it again. This time we're going to put in incorrect information. Denied. Okay, good. So it's working fine now. What would be the correct PIN to authenticate in the locker script? Well, that's going to be 7385, like so. Okay, awesome. Task number 6, practical exercise. And let's see what they say here. We have placed a script on the default user directory, home user, of the attached Ubuntu machine. The script searches for a specific keyword in all the files with a .log extension in a specific directory. Some changes are required inside the script file before you execute it. When you open the machine according to the instructions attached number 2, you will be able to gain the session as a normal user. However, we recommend you become the root user in order to search for the flag in all the files of the given directory. To become one, you only need to type the following command and enter the password. All right, so let's go ahead and do that. Sudo su. And let's see, you can make the changes in the script file by keeping in the view. You can make changes in the script file by keeping in view the following detail. What? Okay, whatever. Flag and directory. Look for empty double quotes inside the script file and fill them. Make sure not to leave any space between them. Okay, so go ahead and try to figure this out and then come back to the video. It says which file has the keyword and then where is the cat sleeping. All right, let's take a look at this script real quick. Now there are some areas we have to edit. The first one is going to be here, flag equals. Be sure to plug in that particular text here, which is the flag. Okay, so that's the string we're going to be searching for inside a flag variable, all right? And another one is this here, so where it says for file in inside these double quotes here. We're going to put the directory variable inside of here, okay? So we know where to search, and that's where we have defined up here. All right, the directory is going to be the var log as specified here. So make sure this information is filled in up here, okay? So it knows where to search on the system. All right, and let's see, the grep is going to be the $ flag variable, okay, which is right here, and then the $ file as well. All right, and that should be it for this. So let's see here. Yeah, that should be it for it. And once you have everything in there correctly, we're going to exit out of here. Now be sure to switch to root as it said. Okay, you can find that information from the login credentials we used earlier up there. Okay, to switch to root. Now to fire it off, okay, make sure it's first chmod plus x, okay, which is starting to be that way, and then we're gonna do the uh, the $ or sorry the dot forward slash, and then it's going to be the flag hunt.sh. Okay, so there's our answers here. What file has the keyword? Well, that's going to be authentication log, as we found it here. It says flag found in authentication log right there. And it says, where is the cat sleeping? Well, it says the cat's going to be sleeping under the table. And how do we know that? Well, we're going to cat the file, okay? So cat and var log, then, so there we go. The cat is sleeping under the table, and there's our flag text as well. So there's your answer for those. And task number 7, we are going to close out. It says, in this room, we studied the importance of shells and flew to the world of Linux shells, exploring their major types. We gained a good understanding of shell scripting and its role in automating tasks. In the end, we created some cool shell scripts and solved a practical lab pertaining to a script that finds mysterious things out of different directories. And we complete the room. So that wraps up this video. If you found this video of value, educational, you liked the video, hit that like button, helps out the channel, helps get the video out there. If you are new here, hit that subscribe button so you know when I post a new video or new information. Share the video, comment below any thoughts, opinions on information shared in the video. As always, thank you all for taking time to watch my video, and I will see you later. Have a good one.